Hey everyone, Filament with Dia's Creative Studio, and this is not the video I thought we'd be making this week. Initially, we were going to print Paul 85's small modular marker tower system found on MakerWorld, and do some 3D scanning with the RevoPoint Miraco. I thought that would be a fun learning experience since I haven't had much of a chance to do any scanning since I got my hands on the machine last month. However, my printer had other ideas. We'll get to the 3D scanning someday, but this week we're going to diagnose and correct one of the trickier printer problems that I've encountered. And we'll take our parts from looking like this to something more acceptable. Let's go. This is the part I was trying to print when I discovered I had problems. This can happen from time to time with 3D printing. You'll have everything dialed in, your machine is printing great, and suddenly a problem crops up out of nowhere. Troubleshooting these issues becomes a necessary skill, and it shouldn't always depend on advice from Reddit. They're just going to tell you to dry your filament and wash your build plate. Seriously. First, let's take a look. From this angle, it's clear as day. Something is wrong. This is ugly. You can see poor layer adhesion, we have blobs and strings. This looks like a fish scale or something. The walls are showing artifacts. It's a mess. So, what do we do? Well, first, this is a fairly large part, so I'm not going to print it again until I can correct the problem. And to help identify the culprit, we're going to do a benchmark print. One that tests different specific pain points of FDM 3D printing. Thankfully, there are many great free options for this. The print I have been using is the Cali Dragon by Magaibeer over on Thangs. Link in description. I use this same model to test my print profiles and to validate upgrades or changes that I make to my machine. The model itself is small, prints in about 15 minutes, and has a range of features that make it perfect for testing. So let's load one up and see what we get. To rule out the material being the problem, we first want to make sure the filament is dry and ready to use with a trip to the dryer. Plastic filament can be hygroscopic and it absorbs moisture from the air, which can cause havoc on the melted plastic as it prints. There are lots of great commercial options for drying filament available now, but I opted to make my own using a SHT-2000 controller, a ceramic heating element, computer fan, a DC motor, and a few 3D printed parts. It works great and allows higher and more consistent temperatures than any of the similar commercially available options. What do you guys think? Should I do a video about this thing as well? Let me know in the comments. Once we have the filament dried, we can give it a go. Okay, so here we have the same issues that appeared on the part we needed to print. The surface quality on this is just trash. We've got blobbing, stringing, outer walls that are sagging and poorly adhered to the surrounding layers. Oddly enough, one side of it looks pretty good. One online resource I use when dialing in my prints is Simplify 3D's Print Quality Troubleshooting Guide. I'll put a link to this in the description. It's got a good list of most print issues along with photo examples. It's really helpful for identifying specific problems and providing potential solutions. So let's head over and see if we don't recognize any of the issues with our print on this list. Maybe it's too hot. That looks about the same. Maybe it's too cold. Alright, that is inconclusive. It's got to be a cooling issue. Maybe there's uneven cooling. That would explain the location of the defects. Maybe too much cooling. Okay, too little cooling? Let's try a new filament. Now let's change the orientation of the model. Alright, the same defects, and they are in the same place on the machine, the northeast corner. It's gotta be a mechanical issue. Let's start looking at the physical fixes. Are the belts too tight? Are they too loose? Was this printed too fast? Okay, so far all these changes have had pretty much the same result. The last place I had to look is the physical nozzle itself. I had recently increased from a 0.4 to 0.6, and this nozzle was a new addition. And if that doesn't stick out to you, that's fine, because it didn't stick out to me either until I said it out loud like that, and had already printed a small, ugly dragon army. If you're having issues and you've made changes, always check the new things first. Fortunately, I had a backup nozzle, and do you want to guess how the print turned out after the nozzle swap? You guessed it. Perfect. It was the nozzle this whole time. So let's take a closer look at that ruby, looking at this under the microscope. And there's our problem right there. Talk about a volcano nozzle. This thing is looking like Mount St. Helens. No wonder we were getting uneven extrusion and poor quality. It's amazing how hard this was to spot without magnification, especially when it was covered in melted plastic and still on the machine. Before I reoriented the part, the defects from this busted nozzle could very easily be attributed to other more common issues. And so that's how I spent my time this week. Thanks for going on that journey with me. I definitely learned something. Every time that there is a problem with the printer, it's an opportunity to learn something new and get a better understanding of the machine and this hobby. Happy to say that we're back up and running, quality printing, and I'm excited for what's in store next week. Don't forget to hit the thumbs up if you liked the video, and if you haven't, subscribe to the channel. See you next week.